Hey there, and welcome to day 4 of my personal Computer Science Education Week challenge. I've got something a little different for you today, or at least it's something that was very different for me. Up until now, the projects that I've built, I've at least been somewhat familiar with the technology that I was using or the programming language that I was using. For today's project, I decided to try and wrap my head around the processing language, which I've never really used before. My introduction to it was when a student came to me and asked if I'd seen a YouTube channel called The Coding Train, which massively deals with simulating physics using the processing language, or at least they're the videos that I've watched a whole lot of. And that then introduced me to the owner of that channel, Daniel Schiffman, who also has a website called Nature, or a website that's addressed at natureofcode.com. Now, if you're at all interested in physics and if you're at all interested in programming, I can't recommend this website enough. As a physics teacher that likes to code, it's fantastic. So Daniel Schiffman is creating, or has created, an online textbook essentially that discusses physics concepts, but then supports them with simulations that he's made using the processing language. Now, you can also, with a small donation, access a Kindle or a few other file formats, versions of this book that you can download also. So please do check out that channel. It's been incredibly useful to me, and it's actually inspired this entire challenge. So in order to try and wrap my head around the processing language, I decided to try and toy with Daniel's own code. So you can see I've kept the comments at the top here, that this has come from Nature of Code. It's Daniel Schiffman's work. And I've just tried kind of tinkering with that and seeing in what way I can change it. There are 2 versions available on the Nature of Code website. The code that you're given is for a non-draggable, a non-interactive pendulum. But the code for an interactive pendulum, one where you can actually click the bob and move it, is available in a GitHub, a public GitHub repository. Unfortunately, I couldn't get the draggable pendulum to work immediately, so that was a bit of a learning journey for me, and it meant me having to try and incorporate aspects of the pendulum code on natureofcode.com that did work with the draggable, clickable functions from the GitHub repository that I couldn't get to work. Now, I don't know if that was a me problem. I am very, very new at this. So I don't know, maybe somebody who knows a little bit more about the processing language might access that GitHub repository and find the code is in fact perfectly fine. I will link both the repository and natureofcode.com to the bottom of this video for anybody interested. So let's have a look at the code that I've been playing with. We can see right at the start here that we're defining a class that we've named Pendulum. And right off the bat, we define a couple of data types here. So we've got 4 data types for the length of the arm, which we've called R, obviously harking back to the idea that the length of the arm is effectively the radius of the oscillating bob. We've got another float, which is the angle, a float for the velocity and a float for the angular velocity and the angular acceleration. So floats mean that we're getting a data type that has a number, and we have decimal places that we can use as well. So that's different from an integer value. We've also got these classes called p-vectors that I've not used before. These it's the first time I'm seeing something like this in processing. And a p-vector seems to be a data type or a class that can store 2 or 3 values. So that's either the XY component or the XYZ component. So they're, I think, used quite often for determining position on the canvas. So you can see I've got the canvas sketch here. So we're using two p-vector classes for the position of the bob and the position of the arm origin, so the top of the thread, so to speak. Oh, sorry, we've got two other floats that I've missed as well. So we've got the ball radius down here, and we've got the damping amount as well. So let's tidy up that code a little. There we go. And then we've got a Boolean, so a true or false value for whether or not I'm dragging that pendulum bob. So has there been a mouse click on that bob? Is it being dragged from one position to another? After that, we've got the constructor for the actual pendulum object. And then we've got these void functions. Now, I deal with void functions when I code in Arduino C, and I'm fascinated to see how similar and where these similarities come from between processing and Arduino. I really am quite new, quite green at this. So a void function, to my knowledge, is just a function that doesn't return anything. So we're not expecting that to return any data. This void go function is actually just calling three other functions that I think we define just below. So there's updating the position of the pendulum, so the thing that makes the whole thing go. There's defining the display, so that's everything that's on this canvas. And that's the bit that I have edited. I'll come back up to that in a second. And then when we end that pendulum class, so we've got another void function for whether or not it's being clicked. We've got what to do when we stop clicking it, so when the mouse isn't clicked on the bob. And then that's the end of the pendulum class that we made all the way up here. So most of the code is wrapped up in here. And then we just call those functions within the void setup and the void draw. And then we've got, well, what happens if the mouse is pressed and what happens if the mouse is released. So that gives us that interactivity with the pendulum bob. So how have I changed this? Well, initially it was just a pendulum that you could click on and you could drag it, and that was nice. That was nice. It was good that you had that interactivity. All I've added is the text that you see below the pendulum. So you can see here we've got angular acceleration and angular velocity, but underneath that as well, I'm drawing a rectangle using everything's using processing, but I'm drawing a rectangle, and the amount by which the width of that rectangle, I suppose you'd say, the width is determined by the angular acceleration for the rectangle that's underneath angular acceleration, and it's the width underneath angular velocity is determined by the angular velocity. So right now the pendulum's not moving, so these rectangles are pretty narrow. They don't have much width. What you'll see is as soon as I click on that pendulum and drag it up, so I start it swinging, let's let go. So now you can see actually a value. So we're transforming the value of angular acceleration, angular velocity into something that we can read almost graphically. Now I'm hesitant to say graphically because there's no axes here that would indicate the actual value, but at least we're getting some qualitative idea of the magnitude and certainly the direction as well of that angular acceleration and angular velocity. Now, what's quite nice is you can see how both the acceleration and the velocity are, roughly quarter of a cycle out of phase there. So when my angular acceleration is at its maximum in one direction, that velocity is at the minimum 0. And when the velocity is, say, maximum in the positive direction, that angular acceleration drops to 0 also. So as a physics teacher, I'm quite pleased with that. I think it shows the students a little bit more than the pendulum. So I'm happy with what I've made. I did say at the beginning of the video, it's not a lot, but the learning journey was actually really useful for me. I'm really impressed at how, now I don't want to say easy because I haven't found this the easiest project, but I'm impressed at how well a graphic with some useful information can be made using processing, and it's definitely a language that I want to explore a whole lot more over the coming months. So overall, I think this was a successful Computer Science Education Week challenge, and I'm excited for tomorrow's one. Now, I haven't decided yet if I'm stopping at 5 days, 5 challenges, and in which case Friday will be my last one, or if I'm going to carry through to Saturday, Sunday also. So I'll see you tomorrow for what may be the last Computer Science Education Week 2020 challenge from me. So thank you for following along if you have been. I'll see you tomorrow. Have a great day.